Hey, welcome everybody on a Trusted Firmware M Open Technical Forum bi-weekly. Today is a session for US time zone, and we're going to discuss different library approaches, and this topic is started from January, and still we are having multiple ideas how to do it better. But before going there to the presentation, let me announce a few things. One is restructuring of TF-M source code. Currently, TF-M, everything related to TF-M are placed in a single repository. And it was fine when the project grew up, but now I think we need a more organized way. So we plan to split the repository on several parts. So the source code separately, and binaries and tools. So the first step is to introduce the folder for TF-M repos and move the current repo under this folder. But to keep your compatibility with your projects and the documentation also, before we didn't update documentation yet. So the old location will be available, but working as a reference link to the new one. Currently, I think in the half a year should be enough to adjust our project's documentation, but let me know if you think some other times, like 3 months or maybe 1 year is better, or more comfortable for you. Do you have any questions? Or anybody? Anyone has a question? Okay. Second thing, recently there was announcement again about the proposal for the hardware abstraction layer change. Currently, you can view the new design of the new hull, and please take a look and comment what do you think about it. It's quite a big job. So currently, it's only one part of the hull changes. It's for core. So it should be not visible or almost invisible for platform and customers who are using TF-M, so it will be inside TF-M. But the second part will touch the devices and secure part. So that will require more attention from you. So currently we are talking about only core hull. And I'm not sure Edison is here. Probably. I do not see. Ah, Edison, if you want to add anything, please.
Yeah, so the plan is just push out the new design for the reviews, and maybe I can give introduced in the next tech forum about the more details. Yeah. Okay. So first, please comments are welcome. Yeah, thank you.
Yeah, before the next tech forum, when we plan to answer questions on the new hull, so this is the time for review and familiarize with the new design. Another thing about the recent changes with the profile. So the profile small is almost done. I think we already reviewed several times, but don't see. David, are you here? If you want to add anything.
Yeah, we just merged the profile small design document. So currently we are requesting the review and comments on the patches to enable the profile small implementation, reference implementation. But the comments and the, suggestions is always welcome. We can continue improving and specifying the profile small design and the use case. Yeah, so please help review the patches. So and let's see what improvements we can achieve. Yeah, thank you.
Thank you, David. That's all news and announcement what I planned for today. And let's go to the main topic. So, Andrew, Thank you for proposing and taking care for improving this handling function, secure function handling mechanism. Yeah.
Okay.
Stage is yours, please.
Right. So I was going to first of all do a catch up on what Ken and I talked about 2 weeks ago. So let me see if I can reduce the amount of little videos I've got on the screen. Right. So this is an update on the presentation we had last time around the handle management enhancements. And there was one particular piece of feedback we had during the call, which was what to do about service versions, because if you have two different bits of client code which have different version requirements, the default handle seemed to lose that information. And actually encoding it in the auto connection during initialization wasn't necessarily going to work well, because it depends on the build time between the client and the framework and the service. And unless you're building everything together, that's not guaranteed. And we've also had further internal discussions about how we might achieve the auto connection. And we think we've got a slightly cleaner solution, which actually puts it all in the SPM. So I'm not going to review the actual main part of this slide deck as we covered it last time. Those slides are actually in the forum wiki, and these ones will be there after today's call as well. So we haven't changed any of the actual analysis. The problem statement is still basically the same. We've clarified a little bit more about the route you go from thinking, well, can we use global variables, and why that isn't always going to work well, trying to abstract it. The abstraction itself has challenges, and the proposal to say, well, what if we have a build time handle which can be baked into the client, which works? So this is the idea that we've got a known handle value which has a different lookup mechanism inside the SPM to identify the service, so that we don't have to call connect and close for simple APIs. So this might be kept the same, and although what we've also then said is right. So in the actual proposal is that there's a separation between what gets declared in the manifest. So in the manifest, you might define the index for a default handle, and this is a small number, and the actual range is going to be defined by the implementation. But the idea is that this is going to provide a high performance lookup in a table. The actual value for the handle will be determined by the implementation, and they'll encode both the index that's specified or allocated, but also the service version will be encoded into the value. Now, we realize this might limit the number of versions you might have in a service. Possibly you'll only end up with 16 bits worth of version, but we think that's probably more than adequate. The implementation will decide how to encode that into the handle value, and all the implementation needs to do is ensure that those values are not the same as the ones it generates when you call PSA Connect. The indexes have to be distinct for different services, so obviously that would mean you end up with different values. So just like the service ID, and the version are encoded in macros by the tooling, the actual value would end up being put into a macro which is named after the service in the same way. So the fact that the implementation actually decides what the value is covered by the fact that the source code just uses the handle name. And the proposal, although this is not necessarily a requirement for the specification, but it appears as if the handles are connected during the first PSA call. So the first time you use call with the default handle value, a client will actually make a connection to the service, but it will happen without the client code having to do any of that work. If you make an explicit call to PSA Connect, you get a different handle value. So you get a normal kind of handle. If you try and close a default handle, it's a programmer error. So default handles are special because they just exist and you just use them with PSA call. And that's the intended client use case. So we've updated the implementation details. So within the manifest, you'll declare a service. It'll have a name, a version, and a handle. And then the implementation will take those details and create the default handle for it, service A handle, and actually will encode both the index and the version number into that value. And then when you want to use it, you just use the actual default handle name in a PSA call, and the framework will just make that work. And this is Ken's current view of how we might make the auto connection happen. So there's previously we looked at whether you might have part of the runtime library set this up before the partition starts running, and it seems that it's going to be cleaner and involve less sequencing concerns if we actually implement it just in time on the first time the default handle is used in a PSA call. So within the SPM, there would be some standard checks about the handle being valid, creating the actual, taking the call parameters and building some kind of message object within the SPM. And at that point, if the handle is a default handle and it's not currently connected, we would then verify the version from the handle and in fact switch the message to being a connect message followed by the request message. So it would then deliver the first connect message to the secure partition. Once the partition replies to the connect message, it will immediately deliver the actual request message to the partition without returning to the client. So there's more details that Ken didn't put into the slide here, but we're pretty confident that with a fairly small amount of overhead in terms of the footprint for handling a message, which can be a connect and then a deliver and then a message, that we can essentially connect these default handles on the fly when the first request is made on them. The rest of the details are basically kept the same. So I don't know if we had any further thoughts based on the proposal we discussed 2 weeks ago, or whether there's any feedback on the updates we've mentioned here today.
Any questions to Andrew?
I have a question, if I may.
Yep.
You mentioned that the secure partition manager will basically understand and try to auto-connect. What will happen if the auto-connect message gets rejected?
Then the call will fail with a connection busy or connection refused, in the same way that PSA Connect would have returned those if you tried to connect using an explicit connection request. Although this appears to add a failure mode to the call, in the previous, without this functionality in place, the client would have had to call connect, then make the call, and then close the handle that it had temporarily connected. So the actual client API would have been in a position to fail with a connection refuse or a connection busy anyway. So the fact that that might now come out of the PSA call rather than an explicit call to PSA Connect doesn't seem to be a significant change in the sort of API signature. So from the root of service, the client, the application's perspective, using this API, this root of trust service API, it could still fail with the same kind of problem. Does that make sense?
Yes, as long as the client can understand why it failed, and also as long as they're aware that there are new error messages that might come back, because they might be doing some sanity check on their side. Yeah,
I mean, we wouldn't. The idea here is primarily because we expect most services are written as a C API that wraps the connect, call, and close. So the actual wrapping API, instead of calling connect, then call, then close, or trying to stash a handle somewhere, it will now just use the default handle. And if it previously had logic to deal with connection failure, it then has to provide the same logic to deal with connection failure that might be returned from PSA call. So it doesn't seem that this, I mean, it needs to be documented carefully so that it's clear that PSA call can return these errors in the case of a default handle. But it doesn't seem that it will significantly change what needs to happen on client side within the actual root of trust service code.
Okay, thank you very much.
Hello. So I think these are good solutions. So what about other solutions? For example, what about we only connect the secure partition when the and the first times and for the other service call. So we don't need to use the to connect every service every time, and we just need to connect the secure partition and once time, and we use the secure partition handle to as the first input parameters and for every service calling. So is it possible so that we don't need to connect for every service? I think.
The challenge there is it changes quite. At the moment, the model, the programming model is that you send requests to a service, and at the moment, a service is a particular sort of what looks like an input queue of sitting behind a signal, so a message queue that's behind a signal in a secure partition. This partition developer could decide to write everything in one service, so use a single service ID and then use the message type as a way of deciding what's requested. And so then it basically moves a sort of like the message dispatch logic into the actual service handler, which then has to decide, okay, well, what type of message is it? And you only end up with one message queue per partition. The design of secure partitions and the separation of the service from the partition was because you might define two completely different APIs, for example, for storage and for cryptography. But for implementation reasons, you decide to actually put them in the same partition. And you don't really want to rewrite all of your, the actual service messaging protocol just because you put them in the same partition. You just want to maintain them as two separate service IDs, but actually just integrate them into one secure partition. So the separation of that is deliberate so that it gives you some flexibility as a developer. If you want to provide just a single service so that you've got one entry point and you're only using one default handle for all the services going to that partition, that's a design decision you can make, but it makes it harder to integrate code or reuse code if we make that a requirement that there is only one service per partition. So, and although I don't think we could easily get routing to the right service or the right signal without separate, if you had a default handle for a partition, you then still need a way of identifying which service within that partition you want to send a request to. So it's a balance between just the concern that default handles will be a limited resource. So they're good for small systems or for very important services. But if everybody wants them and they create lots of services, then the integration will fail. So there's a certain amount of let's see how this goes and how useful they are, and whether we can encourage service developers to use a small number of services to achieve their implementation goals rather than lots and lots of services.
Okay, thank you.
unless there's another question right now, I'll plan to move on to the other thing I was going to present. So, were there any further questions on this default handle proposal? Feel free to put them on the TFM mailing list if something comes to mind later on. At the end of the last session, I talked a little, because we had I think it might have been Reinhardt, but we had a question which was about, was this the right way to solve this problem? And I talked a bit about the fact that this really needs to be viewed in the context of a slightly larger problem space that we're trying to address, which and that we have the outlines of a roadmap, but it wasn't written down properly. And so I've spent the last 2 weeks actually writing down what we want to try and achieve, which is really related to an update to the PSA firmware framework specification. So version 1.1 of the specification. And let's see if I can bring that slide deck up and then check it's actually the one being shared. So have we changed to a different slot? Have we changed to a different set of slides on the call?
I see.
Yes.
V1.
Yeah. It says roadmap to v1.1.
Indeed.
Okay. So this is about, so the wider context is trying to solve some problems around the whole firmware framework at the architectural level, as well as then actually doing that in collaboration with TFM. So we have an architecture that actually tracks the implementation and vice versa. And the subtitle down here, introducing a secure function model, is kind of a hint at what the main objectives here are. So this slide deck has got a little bit about what the purpose of the update to the architecture is, some of the context, which is where we are today, and some analysis of the challenges, and then an outline of the proposal, and then a brief set of, well, 7 steps, which is the roadmap to get to 1.1. I'll explain why we've kind of put it in as a roadmap rather than saying, well, it's just another version. So the original scope that I was basically given for saying, right, let's have an update to the firmware framework. And the approximate scope was any important enhancements that we have to the existing framework, so the IPC model, and include an architectural definition for what TFM has as the library model. And the technical challenge really was that second issue was that the library model looks like an entirely different architecture and a completely different API. So if we want to include it, we end up with a specification which describes 2 different architectures that possibly have even less related than AArch32 and AArch64. But that was it seemed like it would make it challenging, and it wouldn't necessarily solve one of the underlying issues, which I'll come to. So working more recently with the TFM team, we think we've actually got a way that mostly addresses both of the objectives without actually splitting the architecture. Because what we're really trying to achieve is have an architecture and implementations that can scale better between the IPC model for complex systems and the library model for simple systems. And the roadmap here is providing a context for each of the steps that we're going to propose along the way. Default handles was step 1. At the moment, the roadmap is only an outline. We've thought in different levels of detail about some of the steps, and there's a fair bit of room for discussion and rethinking about the details of some of the steps. So don't look at this roadmap as being this is exactly where we're going and how we're going to get there. We'll be sort of finding our way as we go, and there'll probably be more presentations in this forum as we sort of like work out some of the details of the following steps. So the context, and this is probably something you may be familiar with because these are issues that kind of crop up, or issues from this crop up in this forum quite a bit. So the IPC model, which is what the one specified in the version 1 PSA firmware framework. Services are deployed in secure partitions, and a secure partition is programmed like a C program. You have an entry point, and then you're in control of the execution. And in your execution, you will effectively poll or wait for messages. Well, we'll poll for events, and it might be a message, it might be something else like an interrupt signal. And then you write code to respond to that, and you return to polling for another message. So it's more like a traditional C program in that respect, or something that's using a POSIX select call. The communication API presents a session-based connections to secure services. So clients are expected to connect and then use the connection to make calls. And the connection gives you some allocated resources for making the call, so the call shouldn't fail on the way through. But it also provides a way of attaching resources to a connection, which can be useful from a service point of view. The requests are structured, so there's a set of input parameters or buffers and output buffers, and the requests are synchronous, so the client blocks until the request is replied to. The framework provides a secure client identity, so there's a reliable client identity that the service can rely on to be correct. That allows you to have delegated resource ownership. So if you've got more than one client, the service can manage resources for a client without confusing clients or clients being able to spoof another client. Services can use the same API to connect and make requests of other secure services. So the intention is that you'd end up with effectively the same client library running for a non-secure application to talk to a service as for a secure service to talk to a secure service. So the contrasting library model, which is the TF-M implementation that was first developed, in that the services are functions, and the functions are invoked by the framework within the secure processing environment. So the context for execution is something the framework defines, and it's like a callback to the service function. And when that callback returns, then the request completes. So each service function has a request from a corresponding client-side function. So that's the idea that you have there's a client function, which when you call it, it basically takes the parameters through the security boundary, through some dispatching code and into the service function. Each request is a singleton. So there's no concept of a connection. The request is made, it does the processing, it comes back. So if you want something that looks like a connection, it's a construct you build at the application level or outside of the actual library model API. The requests are structured and synchronous now, so it uses IO vectors to be able to validate parameters on the way in and out. There is technically only one client, because the basic implementation of library model is you have a secure environment with the services and a non-secure environment where the client, which makes the calls to the services through the API. So at one level, you could just assume that if a call has come through the service gateway, then it's come from the non-secure side. If you want to make requests of other services, it might be most efficient just to directly call them, because you're running in the same context. The library model was initially designed with isolation level 1, so all the secure side is in one space. So that's a sort of like basic overview of the main characteristics of them. And what it turns out, the IPC model, as I designed it, was good to be flexible. It can handle complex systems and complex requirements. Service developers can manage the execution with their secure partition. So if you have 3 services, you can decide which service you respond to first, even if all of them have a message outstanding. The one thread per partition execution model is easier to think about and analyze if you're integrating more than one secure partition. And it's partly the intention that secure partitions should be isolated, if not physically, at least logically from a software perspective, they shouldn't be actually interacting with memory that's shared between secure partitions. It's clear that not all frameworks can actually enforce that separation, but certainly when writing a secure partition, it should be written with an intention of not using shared memory. But that makes it easier and it's more modular, so actually integration of more than one secure partition from more than one developer is an easier job. The API design requires that request data is copied between the client and the service. This mitigates a number of common service implementation vulnerabilities, that certainly the vulnerabilities that have led to trusted application and trusted execution environment compromise and exploitation in quite a few published exploits for mobile phones particularly. In contrast, the library model is very good for simple systems. It's easy to describe. It leads to very simple implementations where there's only a level 1 isolation. And at the moment where you've got no concurrency, because you don't need multiple stacks in a secure environment, and you're not having to worry about concurrent execution because you have consecutive execution. And direct access to client memory is assumed in the API, but this reduces the overhead of copying data, which is a significant concern for simple and constrained systems. The challenge is that system and product requirements aren't binary, either complex or very simple. There's a spectrum of complexity and security needs, and that's come up many times in discussions on this forum and on the mailing list. And when you've got a system that falls in between those 2 points, which framework design should be used, and can it adapt to your particular set of requirements? Can you make the IPC model a bit more efficient? Or can you make the library model scale to concurrent execution or possibly higher levels of isolation? And that's, at the moment, not very easy. So the IPC model doesn't scale down very efficiently. So specific examples, if you have a one-shot secure operation, you need a connection. So you need to store it somewhere, or you need to allocate it temporarily. And that costs you memory footprint or performance or an abstraction challenge when you're trying to stash the handle. If you've got very simple services, you still have to write the actual partition main loop that deals with signals and dispatches them off to and gets messages and dispatches them off to the service handlers. The library model, in contrast, you just write the service function to deal with all the requests as they come in. And the framework has to manage an execution in context for every secure partition, because the thread model says you need an execution context for every secure partition, and we have to switch between them to process requests. We can't just kind of run the request on the stack we're running on now, because we have to return from a function. So that means we need a separate stack and a separate thread, and we got to do context switching. So this all adds overhead to making requests and makes it difficult to make it really efficient. The contrast is the library model doesn't scale up safely. It's also not very efficient to scale it up, in the sense you lose the efficiency in the terms of when you do the scaling, but it also becomes challenging to maintain a safe, secure system. So just adding more isolation domains, so you go to level 2 or 3, breaks pretty much all of the simplifying assumptions that makes library model so attractive. You've got to isolate services from the dispatcher itself. You need a client identity, because you might have more than one client now. In particular, you could have a service which is a client or a non-secure environment. If you want to call from one service to the next, you can't assume that they run within the same context, and you might have to go the same isolation context. You have to go through the framework. And services need different execution stack, certainly from the dispatcher, but possibly from each other as well. If you want concurrent service execution, then you need extra execution context, because you can't run them all on one stack. And depending on the isolation model, you might need synchronization and synchronization APIs so that you can use shared data, or a sort of like an implementation guide that makes sure you don't use shared data, so you avoid the need for synchronization. And the direct client memory access requires that every service needs to be reviewed carefully to mitigate the errors which the IPC model API prevents by API design. And that's a trade-off that library model made for efficiency, but it requires an inefficiency in terms of being very, very much more careful with the actual software development inside the service. And it's every service that needs to be reviewed to verify that it hasn't made mistakes with the memory handling. I'm going to pause for a minute because there could be some questions that have been queuing up to be asked here. I don't know if there's anyone who's got any questions about what I've covered so far, or wants something to be clarified that I've said.
Yes. I want to remind that the chat window is also available for questions, so feel free to write your questions as well. It's empty at the moment.
I haven't checked if there are any. I haven't checked the chat window, but so what our proposal is to well, there are already some ideas to tackle some of these challenges. So we've got there's been an idea within the TFM team for a while to basically modify the library model API so that service functions by default use a similar kind of approach to IPC model, which is that they have to call APIs to read and write the client parameters, with possibly an extra API that gives them the ability to recover the direct data pointer where they need it for efficiency. But that most of the code will end up with a layer which will protect them from some of the vulnerabilities that you get by reading and writing untrusted data. The default handle proposals, so that was the one that I've just did a refresh on, looks at optimizing the client-side code for one-shot services. And then a month ago, we had some discussions both on the mailing list and in the forum on having a multi-threaded single scheduler model. So the idea of being able to have concurrent secure services running under the control of the normal world scheduler. So it looks a bit like the library model, but without a big lock that says you can only enter secure side once at a time. And the comment I made last time is that these all make more sense if we can actually see a larger roadmap that aims to address all of the main challenges. So the roadmap we have here is introducing changes that when you combine them, they provide an API which says it's possible to implement a framework that is as simple as a library model, but actually looks like it's part of the same architecture as the IPC model. So it's a bit of a hybrid between the two in terms of borrowing the API from the IPC model, but actually trying to achieve the ability to have a very simple implementation if the conditions are right. We'll come to that. It will add options for service developers that provide the ability to simplify implementation of both client and service code. So this is particularly targeting trying to make the IPC model more efficient. So the default handles is one of those. But the idea is that we can actually remove some of the overheads of the IPC model where services don't need them. And the ultimate goal is that if all of the services specify that they're using the simpler handles and service functions, secure functions, that it actually becomes possible to use a much simpler implementation of the framework. So although the architecture seems to be a single architecture, you could actually design a specific implementation for very simple systems which are using just the simple parts of the architecture. But that there's an easy sliding scale that you can essentially get more complex without having to rewrite all of your code. It does require some clever design on the framework side, but we think that's doable. And we want to try and unify to some degree the approach with the interrupt handling between the two programming models, again, so that there's a sort of a continuity when you're migrating code that works within something that's that works using the secure function model to one that's using the IPC model. So had to come up with a name for this, and based on the existing code base in TFM and the existing use of the secure function term, and it seems to fit quite well, is we want to call something the secure function model. And this is an alternative programming model for code within a secure partition. So it doesn't describe absolutely the whole way the system works, but it's particularly looking at the partition code. It looks like a hybrid between IPC model and library model. So services are implemented as secure functions, like the library model, that are invoked by the framework. But you invoke them by a client call to PSA call, the same way you would for the IPC model. But the actual, the direction of travel from the library model was that the actual client-side framework was becoming more and more unified in terms of the API. In general, we expect secure functions that will be provided with a client identity, which allows you to separate per client resources. So the secure function model doesn't dispose of client identity. And it will have indirect client parameter access using APIs to read and write the parameter data as for the IPC model, which was the intention eventually for the library model to become a bit safer by doing this. So as a result, the secure function model API won't be compatible with library model API. So if you've got services that use a library model, they'll need some modification or adaptation to work with the secure function model. So as I said, if the system is simple enough, the framework implementation can be optimized. And by that, I mean heavily optimized in the sense that it could be very much like the TFM library model design internally. By simple enough, I'm really meaning that you have isolation level 1, you have a single secure partition, and that partition is using the secure function model, and that all the services are using default handles. And then it's possible if that is true for the actual definition of the system, then the tooling could say, well, actually, I'm going to replace the framework with a very much simpler one that actually provides the services required by the actual secure partition developer. That's the aim. I think we're going to have to work, as we work our way through it, we'll see just how close to this being possible. But that's the intention. But what we don't want to do is have the secure function model say, well, you can't have more than one secure partition and you can't use higher levels of isolation. So at the architectural level, a secure function model applies to a secure partition, and you can have 2 secure partitions that use the secure function model, or you can increase the levels of isolation and still use the secure function model within a secure partition. So this improves the code reuse of the actual services, but obviously they'll require more complex framework implementation. A simpler approach could be, well, I can use the IPC model and just provide the adaptation code to make it drive the secure function model. That could work, but it gives the freedom to TFM and other framework developers to identify design points which can provide a better sort of trade-off between complexity and efficiency. The architecture won't specify exactly how where the implementation can make optimizations. We'd like to leave that as something the frameworks can innovate on. Are there any questions at this point?
How does the PSA call implementation within the SPM know how to translate the PSA call parameters into the corresponding secure function?
So at the moment, my expectation is what we would do is the secure function prototype, the actual prototype for a secure function wouldn't take a long list of parameters. It'll take something that looks like a message structure. So at the moment, the IPC model, there's a PSA message T, which basically lays out the request parameters and provides a way to access the actual IOVEC parameters using read and write functions. So we would a secure function would have a different signature to the library model secure function, and I'd expect it would take, at the moment, the sketch that I have is that it will take something like a PSA message T structure, which then can be used to identify the type of message and then make requests to read and write the actual IOVEC parameters. So the distinction is that the actual SPM needs to determine whether the target partition needs to be signaled and the message stashed so that the partition then pulls a message and when it calls get, or whether it uses the framework's implementation of the secure function model, which could be based on the same thing, but it could be more optimized in the sense that it could actually just put the message data in the relevant in the right place and then dispatch the secure function handler.
Yeah, I guess my question was, how does the PSA, the root implementation of PSA call on the secure partition, the SPM side, know which secure function to call? Is it somehow in the manifest that this secure partition supports these message types, and here's the function to call when you get this message type? Or otherwise, I don't see how it knows which secure function to invoke.
So in the secure function model, you would still have a manifest for secure partition. So we're not throwing away secure partitions. So the partition would say, I'm using the secure function model. And what that does is that there wouldn't be an entry point which basically we expect the partition to take control.
Mm-hmm.
We might keep an entry point for initialization, but we'd expect that to return. And then, but what would happen is, for every service, instead of allocating a signal for the service, we would define a handler function. So we might just generate the names based on the service name, or we might use a manifest attribute to define what the function is called for that service. So the service says, so when the S partition says I'm a secure function model, each service ends up with an entry point, which is the service handler for that service.
Got it.
And if you then declare that the service has a default handle, then the client would use the default handle and send the parameters. The SPM would essentially, the handle would map to that service, and that service has a function entry point. So you don't have an entry point per partition for handling services. You have an entry point per service.
Okay, I got it.
I'm not,
just a reminder.
Yeah, I'm not quite sure at the moment with the library model how what the mapping, whether it uses the same concept of services to identify handler functions.
Yeah, just to help Andrew, 10 minutes we have.
Okay.
Probably worth to go through slides.
Okay, I've got the remaining slides now are actually just, this is the outline of the roadmap as we see it today. This is a proposal. As I said, we haven't worked out all the details of the steps, and or even we haven't worked out whether we need all of them or where there are some that we need that we haven't got yet. So for step one was default handles. So that's their existing proposal. So it's build time handles that will allow clients to request one-shot services without making an explicit connection. Services will still receive a connection message at this point with this proposal. So there's no change on the service side to what you see. The second step will be secure functions. So this is the secure function model as a per secure partition option. So I've just talked about how we think that's going to work. And it's still an open question as whether we will use the current exact IPC model APIs or whether we'll develop a parallel set which will have a bit more flexibility in them for optimization purposes. But that we'll probably have more discussions on once we've got a detailed proposal written up for that. So the third step is introducing the ability for a service to directly read and write client parameter memory. So this is currently built into the library model. Moving to a safer API would eliminate this entirely. But for simple systems where efficiency and memory constraints require this to be possible, we want to have an API that actually allows the service to get hold of the pointers for parameters that they need to. By making it an explicit API, it also makes it easier to spot where your code is entering sort of unsafe territory. And reviewers need to spend more time checking that the memory accesses are in fact safe. Fourth step and fifth step are around interrupt handling and introducing a couple of terms. At the moment, the IPC model only has one way of handling interrupts, which is a deprivileged non-concurrent interrupt handling capability. So it's a signal that arrives in the same way that message signals arrive. And if the partition is busy doing something, it'll only get to be when it calls PSA wait that it'll notice that there's an interrupt signal and may decide to do something with that. This certainly isn't low latency unless you're very careful how you write the partition code. And there's been sort of a long-standing request to look at whether we can support a low latency exceptional interrupt kind of service. Now, from a framework perspective, we don't really want to introduce a framework for privileged, that's in running at the SPM level, interrupt handling framework, because how that works will depend very much on the implementation of the SPM and also the underlying SoC architecture. This is something that might be an SPM might provide for specific hard drivers, but running drivers in privileged state is known to be a very good way of getting security vulnerabilities into a system. So it needs to be done with care. So this is about providing a deprivileged low latency interrupt handling capabilities for IPC model partitions. And so explicitly, this is suggesting that the current signals are a second level interrupt handling facility, and we need something that happens before you get the signal. The reason this didn't arrive in version 1 is that this adds concurrent execution, which is a different security safety risk. And we needed to look at how much demand there was for this and how it would interact, but also how it would align with what's going on in the library model. But the basic sketch would be that you have a handler for an interrupt. It runs within the secure partition address space context, so isolation context, but it doesn't have access to most of the normal secure partition APIs because it's not safe to interact with the partition code, which could be running concurrently. Not necessarily literally concurrently, but it could be interrupting it. But the idea is it can actually do some transfers from memory to hardware. It can actually program the peripheral if necessary, queue further processing, and potentially then leave a signal for the secure partition to pick up in its execution thread. And then parallel that is to say, right, well, let's have a look at the secure function model, because in a secure function model, we don't really have the call to wait for signals. So how do we deal with interacting with an interrupt that might run as an exception, a first level interrupt type handler, and code that is dealing with services where your service might have, for example, a service from the non-secure side needs to program hardware and wants to wait for the hardware to finish. And so what it really wants to do is wait for an interrupt from that hardware to say that it's finished. So it's looking at how do we improve the interaction between interrupt handlers and the secure function model code. That's really just a very outline of a step, and exactly what that would look like is going to be work for later. Item 6, stateless services. So this is about another optimization. Can we remove connection and disconnection messages being delivered to services when they don't do anything with the connection message? So if the only thing with the connection message for a service does is reply with success, and they don't use the R-handle services of the IPC model, then it would be more efficient if the SPM doesn't have to deliver this message at all. So the idea is that a service can mark itself as being stateless or some attribute like that, which indicates, please don't send me a connection or disconnection message, just do it all in the SPM. The final step is mopping up any other missing alignment issues between the IPC model and the SFN model. And that's the outline of the roadmap. I have one more slide, which really is saying, look, there's some open issues which require further discussion. There's a few ideas of open issues that below here. And we expect that we'll actually do that discussion as part of defining the details for each step. So we'll probably come back to this forum and have a discussion as we sort of refine the proposals for each step. Some comments were just about things that are worth bearing in mind. The default handles, they can't be a universal replacement for the service IDs because they are a limited resource, and they're a challenge for integration if you've got services coming from lots of places. Just a question mark, do we really need direct client memory access? We would like to at least collect use cases for interrupt handling in secure partitions, because there's some mixed modes which it'd be worth knowing whether we need to support them. The question mark I had earlier, do we want to keep the API the same as the version 1 IPC model API, or does version 1.1 introduce some new APIs which provide a bit more flexibility and optimization? And of course, are there any important use cases which this roadmap is going to leave unaddressed that we ought to consider? So that's it for my slides. We'll carry on working on actually detailing the architecture changes for default handles, and Ken probably has ideas about looking at building some prototype implementations. And we'll be working on writing up step 2. And obviously revising the roadmap if you've got some feedback from yourselves or others. So I know there's only a few minutes left, like one or two.
One or two. Yeah. I finished,
so happy to take any immediate reactions. I can stay on the call for a bit longer, but it might be something that people need to go away and digest better, and then and come back on the mailing list with comments.
Thank you.
Definitely, it's very valuable first, and second, very big change which we expect, and it requires digestion and thinking about it. Yeah, but I see one question in the chat. This is thanks to you, Andrew.
Okay.
Yeah, I think we are just finished on time. Thank you, Andrew, once again. I think this is one of the hottest topics in TFM, what we discussed many times. Yeah, thanks for this overview. I think we all missed this. So the big picture of the whole PSA architecture, not the whole architecture, but how we can implement those handles.
Okay. Anton, I've sent you the slides so you can put them on the wiki.
Yeah. Just wanted to mention, Andrew already shared the slides, so it will be available on the trustedfirmware.org website, so you can take a look once again. Please reply and please provide feedback on the mailing list. So
I'm sorry I didn't really leave a lot of room for discussion. I'll try and make sure there's a bit more room. Won't come back with another presentation next time, so that we can actually have some discussion on some of the things that have been, have come up as a result of this.
Yeah, of course, this is not the last chance to discuss it. I think after study the proposal, I think we will get back to this on the same technical forum and discuss the questions, answer the questions, and maybe alternative ideas. Thanks, everybody. So thanks for the nice technical forum today. And
thank you for the attention.
Thank you.
Thanks.
All right. Thanks.
Bye.
Thank you.
Bye.
Bye-bye.
Thank you.